Okay. All right. Let's get started. So thanks everybody for joining. This is the third in a mini series we have on the O1 Labs side of projects with the O1GS partner program participants. We talked to Snickerdoodle Labs last week, and today I'll just do a quick formal introduction, and then we can get to the real meat of the conversation with Samuel Brack, who is the CTO and co-founder of Dia Data, the Oracle provider, and we'll be talking on the topic of building a ZK application with O1JS, an SDK from O1 Labs. So that's the topic for today. And I'm Phil Kelly. I lead business development at O1, and I'm here with my colleague from the engineering side, Florian Kluge. And we're going to talk for about 30 minutes before opening the conversation up for any wider participation. We'll also be happy to continue on Twitter thread later. I know questions sometimes arise after the call, so look forward to hearing any interesting points that people have. So as I said, this is the third in the mini series of weekly Twitter Spaces. The partner program that this draws from is there to help existing Web3 projects as they get experience building ZK applications that run on the client side. So ZK applications. And that's the way in which you can build privacy into Web3 applications, for example, and then more generally build code that can run off-chain, and in that way avoid gas costs and the latency and data challenges that come with working on-chain, but still be trustless and verifiable back on-chain. So I know that's kind of a conceptual statement rather, but the goal of these Twitter Spaces is to bring that idea to life with some practical examples. And I like that we're talking with Dia. As I said, we talked last week with Snickerdoodle, and that was a privacy example. And actually, in the ZK application space, we often all quickly gravitate to conversations about privacy because that's kind of a very intuitive use case. But I think there's huge under-discussed potential for using ZK applications and client-side ZK in general for off-chain that, in the past people did on-chain. Freeing themselves up from gas costs, freeing themselves up from data constraints, latency constraints, and doing things off-chain trustlessly, and then sending the result back on-chain. And that's actually exactly, I think, what Deer is experimenting with here. And I think that will unlock a whole new range of use cases in the market. So I think this is a cool topic for today. And just a reminder of what O1 Labs does. In addition to building the O1JS SDK, which is how you can build a ZK application, we're the engineering team behind the MENA protocol, which was the first ZK-based recursive L1. I think still is the M1, and it's now in the later stages of testnet for a big upgrade that will make it a great place to verify and settle ZK applications. So that's a very cool thing that's coming shortly, hopefully. We're also looking at new approaches to client-side ZK, so right now, if you use O1J SDK, it uses these super efficient ZK circuits. But we're also looking now at writing ZK applications with VMs. So that's one of the reasons behind the work that we're doing with Optimism's fault-proof engine. And the results of that should be very synergistic with MENA's ecosystem, and in particular, extending the use of our Plonkish ZK proving system. Okay, so the particular ZK application that Dia Data has been experimenting with is a new approach to trustless off-chain Oracle calculations. But Samuel, why don't I let you introduce yourself and the project, and we can kind of take it from there.
Yeah, thanks. Thanks for the great intro. I'm the co-founder and CTO at Dia. So we are an Oracle provider. We have been in the space since 2018. And also seen a lot of technological change in the time. We have seen a lot of cool new features developed in the space, and I think zero knowledge proofs, and especially on this usable level, where what O1 Labs is doing with MENA is super exciting and one of the most interesting developments in the last years. What we are doing is we are collecting a lot of data about mainly crypto assets, but also fiat commodities, NFTs, and so on, and are providing price points, a multi-chain ecosystem. So that means we are not providing price points only on like the big chains, but also always aiming to support new and upcoming chains, because they also need these. There's like a new segment of interesting protocols always being rolled out, and we try to be ahead of the curve, as usual here. And one of the main applications for us is that we want to have a verifiable price feed on chain, where we say we are getting the trades from, for example, centralized or decentralized exchanges, and we want to be able to calculate the price feeds that anyone can understand and verify where they're coming from and how they work. So this is how we are related to O1 Labs, but how we are using the technology of O1 Labs. Currently in like a demonstrator phase, and looking how we can extend this, and did some very cool experiments already with it, and really excited about telling you a bit more about this.
Cool. And so just to ask a follow-up about it, is breadth of coverage part of the differentiation that Diodata provides?
Yes, absolutely. So one of our key differentiation points, I would say, is next to having like a multi-chain approach for where we deliver the data, is also to have a very broad approach about what data we can get. And we're talking about very long tail assets that maybe only traded in two different pools on some curve, on some curve clone on a chain that most people probably never heard of. We try to get the data. So that's our aim, and with that also comes a lot of risk management, because some of these are having issues, for example, with liquidity attacks or something like that. So we just have to have a lot of smart algorithms to check these and to keep a balance on that.
Yeah. So you're probably, compared to, we don't just discuss particular names, but compared to, like some of the super early and very well known names, you're probably more focused on innovation and unusual use cases than a typical Oracle provider, I guess, which may be why we started talking quite early, in fact, about the ways in which you could use client-side ZK to create new ways of providing oracles.
Yeah, absolutely. So I think our target is always to provide also the people who are, or the protocols, or maybe the apps who are not getting a price feed just ready-made from where they can get it at a lot of other places. But where we can say, okay, you can have it either very configurable, so that's one side that we serve, or like a very long tail assets. This is also something where we have a strong focus on.
And what do you mean by configurable there?
By configurable, for example, I mean that we can say, okay, I want to have the price of a certain token, but only from certain exchanges, or I want to exclude certain exchanges, or I want to have like a liquidity measurement that I say, okay, only pools with liquidity more than $50,000 should be considered, and the other ones should be filtered out automatically. Or I can say, I want to combine multiple assets. So, for example, if there's like an asset on multiple chains, I want to combine them and basically take all the trades that can be found on several chains into one price feed. So there's a lot of it's a bit like price feed Lego that you can play here. This is one of our goals, to make this not only possible but also very intuitive for everyone to use.
Yeah. That's good. Well, when I remember when in the very early days of me sort of, becoming aware of oracles, way back when, and understanding how, understand what their purpose was, I had assumed, I think in the early days, that you just, an oracle provider just got a single price point from an exchange or something, and then signed it and sent it on chain. And then, the more I've been involved and talking with you and other people in the marketplace, the more I've realized, the level of, well, first of all, I think mainstream oracles, they're more difficult to produce than that, but they're still quite basic in some ways. And then, you've kind of opened my eyes to all these different dimensions of what you can already do with oracles. And then I think there's a ton more that can be done in the future. When I have a bit of a TradFi background, and when I think about the kinds of financial data that people use in the TradFi world versus in Web3, there's a massive gap. There's tons more you can do, and I think that's probably partly as a result of the constraints that come about from doing things on chain and gas cost and what have you. So
yeah, maybe one creative interpretation of this, you can do more, is MEV bots, because MEV bots they're also using information that's available a bit earlier than the rest of the market uses. So I think there's something very interesting in kind of getting into a predictive model. Especially with DEXs, you can actually predict kind of if you assume that nothing changes, you could predict the next price if you kind of roughly know the volume, for example, because you can just apply the liquidity formula how it would be impacted. So as you said, I think there's a lot of stuff still coming on and a lot of metadata still being exploited. So yeah, this is very exciting and also I think very interesting to see which new products could be structured on there, because we also see that, for example, even though the concepts are very old, but actual on-chain options in futures markets are still not as big as I would have expected to be them a few years ago. Yeah, agree with you. There's a lot of potential for innovation.
One of the things, so I was involved in some conversations on a panel in Istanbul, and one of the things that we were talking about was risk mitigation. And for example, if you're using an oracle to value collateral, you could, rather than just having a raw price feed, you could also have data on depth of market, and also have a price feed, for example, that looked at flash loan activity that might be able to give you the heads up that, this price is an accurate reflection of market price at the moment, but the market might be undergoing manipulation with flash loans.
Yes, yeah, or you could also bring in like weighted sources from other from other areas. So I think there's a lot of places where this can be where this data can be sourced from and how this data can be used. And for that, it's very important that we can get it on chain in a way that that is trustable and verifiable for anyone.
Yeah. So, and before we move to the kind of more technical discussion, maybe it would just be useful for people listening in to talk a little bit about how just plain vanilla oracles work today, and then like what the new approaches that you've been experimenting with ZK. But plain vanilla, I meant on-chain consensus. Do you want to just talk a little bit about that?
Yeah. So basically, yeah, of course. I mean, it's basically usually that you have data collectors from multiple sources. This could be, in our case, it's exchanges where we collect the data, but there's, for example, other oracles that are also collecting already from some pre-calculated prices, and then this data is submitted, aggregated, and then you have at some point you have the price, which is like the outcome that has been decided, and this could be either from these individual trades. This could be from like different people reporting from the same data source to make sure it's not manipulated and so on. At some point, you always have like a collation where you say, okay, we have a redundancy, so there might be like 10 reporters or something, and these reporters need to agree enough with a certain error of margin of errors, so that the oracle would say, okay, this is the new price that is accepted.
Okay, so it's that step where you've got a number of sources of data, and you do something with the data before you emit the as you said quote unquote the price.
Exactly. Yes.
Okay, and then that could be like maybe eliminating some of the redundancy, and then doing some transformation on the data, such as an averaging.
For example, averaging or having just like outlier clearing, stuff like that. And then with zero knowledge proof, suddenly it becomes possible, or it's at least parts of the calculation can be done verifiable, so that you can say, okay, the input data, the calculation, the output data, so you can always verify how that the calculation was done in an honest way. And if it's not done in an honest way, you can pretty much immediately spot it. And with that, then you can basically combine it with staking, slashing mechanisms or other like incentivization to search for these errors. So a bit like having a watchdog always hanging over this whole system, and being able to tell there was an error, and being able to do this automatically without like any manual oversight.
Yeah, cool. So the application use case here is get some signed data in, and then put it into a ZK circuit that will do something with that data, such as eliminate outliers, calculate an average, and the sky's the limit in terms of the calculation you could do. and then emit the result along with a proof that the calculation was done correctly.
Yes.
And that's why, at the beginning of the call, I mean, I don't think probably nothing in that calculation or the data sourcing would need to be private. This is actually not really a privacy use case. It's just a way to prove to people that a calculation underpinning a Oracle price that they've got was done with integrity error, and so they can just immediately trust it without having to, apply a risk weighting to it or redo the calculation or apply any
Yeah.
other. They got the safeguards built in.
Yeah, exactly. It's basically the exact opposite of privacy. We want it to be public so that it's transparent and everyone can see what's happening. And I think it's a bit like if you would be a statistician, you maybe would say it's like subsampling, where you say you can reliably from like a very small calculation or from a very small sample infer that the whole thing was done correctly. I think that's kind of the analogy we can take here, and we can say, okay, even with the small amount of work, you can verify that this bigger amount of work, namely the collation of all the trades and everything, was done correctly.
Cool. Florian, I should probably let you start to jump in here and maybe talk through some of the technical approach, because it's great on these calls to help. I mean, one of the things I like every time I work with a partner, after we've gone through the initial phase of helping everybody get on the same page about this kind of admittedly somewhat strange approach in the Web3 world of doing off-chain verifiable computations, we usually get to this point where we had a pretty easy time in terms of things, and I use the SDK. But yeah, Florian, let you talk through that conversation.
Yeah, definitely. Thank you. So the reason why I think the DA use case is specifically interesting is because it's actually relatively straightforward, but yet super powerful. So what you spoke about earlier is essentially taking some computation and putting it into a circuit and then proving that computation. That's also sort of like known as proof of model. It's a simplified version of what people like to call CKML, putting a machine learning model into a circuit. But instead of using machine learning, you do use certain computations generating or like calculating the price, the output. So could you briefly recap what exactly you're calculating within a circuit?
Yes. So as you said, it's quite simple, and in the first version started with a volume weighted average price. So that means we take because our input data is trades. So we want to, as I said earlier, we want to have an image of the market as it happens. So we always try to get as many current trades as possible. So usually we collect these trades for like a certain time, let's say 2 minutes or 4 minutes. And in this time, we basically collect all the trades we can get. Trades is, for us mathematically, it's just a combination of a price. So, of course, first it's two assets. So it's, for example, could be Bitcoin and USDT, and then we collect the trades for all of these. So, but once we have established an asset class, we say, okay, we want to get all the trades for this one pair. And each trade consists of a price and a volume. So the price could be, I don't know, 30,000 something USDT for one BTC, which is probably a few days old already, this trade. And the volume could be $200. And then we need to collect all the trades, and then we do a weighting by the volume of these prices and calculate an average price. That's a very simple calculation, but nonetheless, in such a circuit, it's already takes a considerable amount of time if you have like several 100,000 or even 10,000 of trades in this time frame. So that's why we started simple. What we also do then later on, we also add things like outlier clearing, where we say, okay, we are putting all of these trades into 4 equidistant buckets, and like the 2 outer buckets of these, they're just thrown out. So that means you can clear trades that are completely out of the order, for example, when they have like a price which is a bit unrealistic, which happens sometimes on DEXs. So we want to be able to filter this. We can do other calculations, like I said earlier, with liquidity, especially when we have trades from DEXs. We can check out what's the liquidity of the pool, where it's coming from. Do we need to scoring here, or can we just take the price? So there's a lot of additional metadata we can take in, but at the core, it's always this volume average pricing that we can do.
Awesome. Yeah, thank you. So I think it's specifically interesting looking at OpenJS and the possibilities you have with it, both allowing users to generate proofs and verifying them in the browser, but also what is closer to your use case is taking some data on a server, on a system, and then generating a proof of it and then providing that proof to the user so the user could then verify that proof in the browser. Have you already, I guess, like, what is the ultimate sort of like user experience, the user flow? How would a user consume that proof? How do you provide that proof? Could you talk about that briefly?
Yeah, so basically what we are aiming for is to have a more systemic integration of proofs, not necessarily for the end user in the browser. I mean, this would be something we would also add, but not as the main feature. The main feature would be more a incentive system. As I said a bit earlier, I think when we talked about how easy it is to verify this and that you can automate this. So the idea would be to have like a community of almost watchdogs, I would say. And they are closely always checking these proofs that are being generated and together with the prices. And then they can get a reward or some kind of incentivization if they find out that something was going wrong. So this is kind of a basically just paying the watchman, if you want to call it like that.
I see. Yeah, that makes sense. I'm actually interested in diving a bit into the architecture on the back end, how the system is constructed. I guess, like, without going into too many details, I believe you're using recursion. Like, how actually do proofs happen? Are they generated on the back end? And how's that system working from an architectural point of view?
Yeah, so one challenge that we found is, as I said, we are processing times a high number of trades. So for some pairs, it's like 4 trades per 2 minutes or something. So these are not the problem. But if we have something like Bitcoin USDT, there's a lot more trades that we want to process. And we were running into some timeout constraints, or not timeout, but some high latency constraints that we wanted to solve. So what is one possible solution to this, I think, in general, and funnily enough, this idea came actually from hardware design experience earlier, that we basically parallelize some of the construction that we say, okay, we always take, let's say, 128 trades, do the VBOC calculation of this, but not only output the price, but also the volume of the whole sum. So basically if you want to call it like that, but we can do that several times, and then we can bunch together these results and then calculate on the results if we will begin. And by that, we can make like a multi-stage process to call these and to have the calculation done in more considerable amounts of size. Why does it work? Because if you have, for example, 256 trades, it's quicker to do 2 times 128 instead of 1 times the 256, because I think the circuits internally, they are just at some points probably a bit super linear scaling, but that's probably something you know better actually. But yeah, that's at least what our experience was.
I think that's an awesome example of utilizing recursion to optimize your backend performance. So you mentioned a very important point. Yep.
Sorry, I was going to say, by the way, what's this space? Because I think, we, along with other providers in this market, there's a lot of advances being made in terms of performance. So it will remain the case that it will always be possible to use recursion in a really cool way to parallelize problems. But in fact, you should increasingly be able to handle big problems without that. But anyway, actually, Florian, you're probably better to comment on further on that than me.
Oh yeah, no, definitely. I'm totally agree. Recursion is like a super powerful primitive. It's something that is at the heart of OpenJS and Nina. So I like when people actually use recursion, which is a super powerful feature that we provide. You also mentioned latency, which plays into the entire recursive system, I guess. What are some latency numbers, proving numbers that you think is acceptable for your use case?
So as I said, we have usually processing time, so we look back at, for example, the last 2 minutes of what happened in the world of trading, and then we want to get a result rather timely. So I mean, theoretically, we could say, okay, it takes 10 minutes, but then no one is interested in a 10-minute old price. So it's something where we are looking for 10 seconds-ish area, and that's where we then put our target line around that. And this is also where we, for example, said, okay, I think with around 200 trades, this was achievable, and then we experimented around a bit, and we got to the point where we said, okay, we need to split this up so to get in this area, but that was kind of our target. But I want to say this was also already some time ago, so it's possible that it's now a bit faster with the newest version of 01.js.
Yeah, definitely. We've done a lot of improvements over the last months and weeks, making both compilation improving much quicker. So I think with a more recent version, you would even achieve better numbers. So that's pretty cool to see. Looking at moving a bit away from the architecture and now looking a bit at 01.js, have you had previous experience with TypeScript, or are you entirely new to the JavaScript/TypeScript world? What was your experience building 01.js?
I had very brief experience with TypeScript, but mainly from like configuring hardhat and stuff like that. So developing other smart contract related programs. But the experience was very nice, very easy. The onboarding is super good. So
Samuel, can you hear us?
Yes.
I can hear you.
Okay, I can hear you as well. Was there a problem with my audio, or?
Yeah, I can't hear Samuel at the moment, but is that just me?
I can hear.
Okay. No worries. Then I go on. Yeah. So basically, the onboarding was super nice, super easy. The documentation I can really recommend to check it out. This is very nicely written, and I really appreciate it because it looks like it was a lot of work to get into this good state. And I think it's also very friendly to use because a lot of the concepts are very well fitting inside this language. It feels very natural to use. So I'm very happy with that.
That's glad to hear. It's always great to see people pick up 01.js and then build something meaningful very quickly, very efficiently. So how many hours did you roughly spend on like getting a first proof of concept out the door?
First proof of concept or first prototype was super quick. I think this was something like an afternoon. Where we had then a first like simple VWAP running. Main issue to get running was in the beginning the setup. There's always you always have questions that are in hindsight are super obvious, but at the beginning not. But as I said, documentation is really good, and we were able to solve them eventually. I mean, the logic we implemented wasn't super complex. As I said, the VWAP is just like this calculation with these tuples. But this was a nice experience.
Definitely. I mean, like I said earlier, the example, the proof of concept is super straightforward, but also insanely powerful. So it definitely like utilizes like all the features and all the important things of 01.js and really elevates the use case. So I think that's super powerful. And thank you for working with 01.js. Thanks for working together with us. I think it was very enjoyable also from our side. We think it's a super awesome use case, very powerful, and is there anything Phil wants to add? I believe he's back.
I am back. Sorry about that. Nope. I think that. Well, actually, I just wonder if it's worth briefly talking about or explaining what recursion is for people who are new to the topic. Florian, is that something that's an easy one?
Yeah, definitely. I can do it myself. So the idea of recursion is that you, instead of simply taking one proof and generating some computation, what you do with recursion is you take a proof and you also prove the verification of another proof. So what that allows you to do is building very powerful application systems and use cases. So for example, Mina is a recursive CK blockchain. And what that means is with every transaction and block being added to the network, a proof is created of those blocks and transactions, and they are recursively verified within the next proof. So if anyone has experience with basic programming, the concept of recursion is simply a function calling itself. And that is pretty much the same with ZK and recursive proof. Instead of calling itself, what you do is simply take a proof and verify the proof recursively and generate a proof of the verification.
Cool, thanks. Yeah, cool. Anyway, so I didn't have any further questions or topics to discuss. Samuel, was there anything you wanted to cover still, or should we open it up for questions?
Oh, I would be happy to open it up for questions. I think it was very nice talking to you, but now very excited to hear from the public.
Thanks. Yeah. And by the way, once again, you are literally the use case that I, discuss every week with people, because it's just a great way to talk about ZK for gas efficiency and computational integrity without like getting stuck in the interesting but nonetheless giant gravitational pull of privacy use cases. So thanks again. Yeah. So anyway, let's open it up for any questions. And if people don't have questions right now but think of them later, then we're as ever very happy to continue on the thread.
Also, maybe if you have questions and want to come to, we also have a Discord where you can ask these later on. So if they are more related to DIA, no worries.
Cool. All right, just give me a couple more minutes here, and then if there's no questions by 35 after, we'll wrap up.
Yeah, I want to say thank you already. It was very nice to talk to you and to be in this space. And always a great opportunity, and it has been a great collaboration so far.
Yeah. And I think our conversation was early. There now is, quite a lot of conversations about ZK and oracles in the industry. And, when we first started talking, they were pretty limited. So I think we made a good bet.
That's true.
Yeah.
Especially, cool. and I mean what you said regarding privacy, I think like a lot of use cases with privacy are actually they're super interesting. But on the other hand, I see this kind of verifiability integrity is like also another attack vector, or not an attack vector, but target that is really underserved and where people could be building interesting stuff. So I think that there could be new technology coming up very soon with this in mind.
Yeah. I mean, it's essentially the co-processing idea, which is more often it's quite often referred to for ZKML, or for the idea of taking like some of the more complex DeFi protocols, could take part of their smart contracts off chain and process them there for gas cost savings, and then send the result back into the rest of the smart contract process. I think that's another verifiable computation use case without necessarily a privacy angle. So yeah, I agree.
Absolutely.
Because they're a little bit less intuitive, they don't as often make it into the conversation. Cool. All right. Well, let's wrap up for the day. Thanks again, Samuel and Florian, and we'll look forward to talking to people next year.
Awesome.
Thank you.
Okay.
Bye-bye.
Take care then. Bye.
Have a good. Bye.